My dear friends, I welcome you all to this third and the last video of this series. Discussing generally, there are two dimensions in the assessment of disability in recent times. The first part is the treatise, which is the manual published in 1981. The methodology was given in Gazette in 2001 and then changed and published again in another Gazette in 2018. I propose another dimension suitable for this age of computers. It is the use of spreadsheet for the assessment of disability. I use spreadsheet to quickly calculate disability even in complex cases without worrying about the methodology or worrying about inclusiveness or calculations or accuracy. While using spreadsheet, all I need is to concentrate on the clinical findings and to concentrate on how to measure the functions. That's all. It is made so simple. Now let us directly go to my spreadsheet. I will explain how the process of assessment of disability is implemented using this spreadsheet. You can download this spreadsheet from my website any number of times. It is free. You don't have to register also. In your laptop or computer, open any browser. You can do this in your mobile phone also, but if you use your mobile device, your view gets limited by the size of your device. Type rammedisoft.com/ul in the URL box. Note there is one double M in this URL and download the file. It is just 50 to 60 KB. Don't worry, it is completely virus free. Go to your download folder. In my computer, download folder looks like this. To make it double sure, do a virus scan of the file again and proceed. Then make a copy of this file in the same folder or any other suitable folder. Keep the original file as such. For the next case, make another copy of the original file and use it again. Give correct name to the newly made copy of the file. I suggest you to give a descriptive name to the file like 835641 underscore humerus underscore shaft underscore wilson dot xlsx, so that it is very easy to find a particular file even when you have hundreds of copies. Double click on this new file. The file will open the default spreadsheet application in your laptop. In my computer, I use LibreOffice Calc. You can use any spreadsheet app like MS Office Excel or WPS Office or any other spreadsheet application. Speaking generally, in any spreadsheet, the smallest unit or the point of entry is called a cell. These cells are arranged in rows and columns. Columns are named A, B, C, D, etc. and the rows are numbered 1, 2, 3, etc. In my spreadsheet, there are two types of cells, black and white cells and colored cells. Black and white cells are the places where you enter observed values or clinical findings. I have kept normal values in these black and white cells. You have to change only some of these values which are affected in a given case. See this picture. In this picture, one of the black and white cells is marked with a red rectangle. In that cell, you can see the default value. When you are examining a patient and entering the clinical findings, find the relevant section and locate the correct function or parameter you want to enter. Then click on that cell once and then overtype on its content. Do that on all such relevant cells. When you finish doing that for all functions, you will get the final disability calculated instantaneously. You are done, or actually that's all you have to do. Colored cells are labels or computed cells. They are not editable. For example, in this slide, the cell with the label flexion immediately on the left side of the marked cell is a colored cell. It's a label. You cannot change the label in this spreadsheet. These types of cells are called protected cells. You may ask how many entry points are there in this spreadsheet. There are totally 90 entry points for each upper limb. But in practice, only a few of these functions are affected. Whatever may be the total number of entry points, all calculations will be done by the spreadsheet automatically and instantly. That's about my spreadsheet in general. Now let us see how to use this spreadsheet. But what about those people who are not having a laptop or computer in the office? How to use this app in such cases? At the bottom end of the spreadsheet, there is a tab marked as a list of functions as shown by the orange arrow in this slide. When you click on the tab, you can see the list as shown in this slide. It fits on one single A4 page. Take a printout of this page and take as many copies as you need. As you examine the patient, ask the assistant to fill the correct empty spaces in this paper form. Then give the completed form to your assistant who is with a computer. Let him open the score sheet section of the spreadsheet first and let him fill the clinical findings in the relevant fields. He has to take a printout of the final score sheet for your signature. Actually, to prevent malingering by some crafty patients, you can take the clinical notes on paper forms at two different times. First, note the active range of movements and some activities with the patient standing and the eyes open. Then check again after 2 hours the same active range of movements and the activities examined with the patient lying and the eyes closed. Enter the higher values from the paper forms in the score sheet. That's all. That helps a lot. When you print the form with a black and white laser printer, it looks like this. When you print the form in a color printer, the same form looks like this. These forms help you a lot in finding malingering and to do the disability assessment even if you do not have a computer in your office. Yes, most of us have laptops or computers. Now let us see how to use this spreadsheet on a laptop directly. Before that, let us see the seating arrangement in my OPD again. It has greatly helped me. This arrangement helps you to quickly complete any case within 5 to 10 minutes. Ask your assistant to make entries using the laptop or PC, and if you do not take the laptop to bedside, take the printout of the form of the list of functions on a writing pad. Make the patient sit or stand or lie down in front of you. You can stand between your assistant and the patient. All you need are a goniometer, a measuring tape and a ballpoint pen to test sensation as suggested in Gazette. When everything is ready, open the correct spreadsheet in your laptop and open the score sheet. At the beginning of the spreadsheet, you can see the areas where you have to enter the details of the patient. Ask your assistant to fill those details. Name of the patient, age, gender of the patient and the date of examination. These values will appear in all the printed pages of the score sheet at the top of the page. Let us refresh our knowledge a little bit. We have to remember these 3 slides for the whole picture. This is the first slide. We can see that the locomotor system is a functional combination of 3 parts. Section A1 is upper limb, section A2 is lower limbs and section B is spine. Remember that the process of measurement in locomotor system is divided into sections. The locomotor system as such is not divided. If more than one section of locomotor system is affected, it is called mixed involvement or mixed locomotor disability. In this second slide, we can see the arrangement for the upper limb and we can see the formula for the medical disability D is equal to I plus C. I or effective impairment in upper limb is a combination of weighted summary functional losses in 2 functional components, namely arm component and hand component, each with a maximum value of 90. Values of the components are combined. Arm component has 3 divisions, each with a maximum value of 90. Values of the divisions are combined. Hand component has 3 groups with a maximum value of 30 each. Values of the groups are added. Complications in upper limb is called additional weightage and you can give up to 10% additional weightage in case of upper limb. In the third slide, we can see the arrangement for the lower limb. Again, the formula medical disability D is equal to I plus C. I is effective impairment in lower limb and it is a combination of weighted summary functional losses in 2 functional components, namely mobility component and stability component, each with a maximum value of 90. Values of the components are to be combined. Mobility component has 2 divisions, each with a maximum value of 90 and values of divisions are to be combined. Stability component has 9 activities, each with a value of up to 10%. Values of the activities are added. Complications in lower limb is called extra points and you can give up to 10% extra points. Let us see the flow chart for upper limb again for few seconds. First comes the arm component. It is the first functional component of upper limb. The arm component has 3 functional divisions, each with a maximum value of 90%. At the end of arm component, losses in all divisions are to be combined into a single value using combining formula 2 times. Now let us take up the first division. This is the appearance of AROM division in my score sheet according to Gazette 2018. Earlier there were arcs of movement. For example, flexion extension arc in shoulder is replaced with 2 values now, flexion and extension. So now in shoulder instead of 3 arcs we have 6 movements. It goes on similarly with the other joints also. Let us go back to the clinical setting. Everything is ready. Your assistant will read out the first point as shoulder flexion. Keep in mind you are examining only active range of movement. You are not testing the passive ROM. You should not touch the patient at this stage. You will show the patient how to do flexion of shoulder, once with the eyes open, once with the eyes closed, and once with the elbow flexed. As the patient moves his shoulder, you can measure the value visually or with a goniometer and tell the highest value to your assistant or note down in the form. Your assistant will click on the specified entry point and overtype on the existing default value. Suppose you enter 80 degrees as observed flexion. Look at the calculations that already gets done in the spreadsheet. You can see the percentage loss calculated, mean percentage loss calculated, and 20% weightage is also applied. As I just told you, when the patient is doing AROM, do not touch the patient, just note the value. Just a few words about the crafty and seasoned victims or malingering. Number 1, check the endpoint of movement by applying opposite force, springy, resisted or bony. Malingering patient usually has a resisted endpoint. You can ask patient to do the same movement on the other side. Patient gets confused and forgets. Malingering patient will show far more movements in the unaffected side. In malingering patient, compensatory movements in other joints will be absent. Going back and forth in the table repeatedly and quickly also brings out malingering. Make patient to do activities not listed in the gazette. The idea is check the active movements with the patient standing and against gravity with the eyes open, and check the same movement with gravity with the eyes closed in the lying down position. Most of the active movements increase with gravity and decrease against gravity. Finally, you can do whole sets on 2 different occasions and take the higher values. Now comes extension. Your assistant will read out shoulder extension. You will show the patient how to do extension. Measure the value visually or with goniometer and tell the values to your assistant. Your assistant will click on the entry point and directly type the value. Let us say patient had no active extension. Let us enter the value for extension as 0. See what happens. Similarly, complete all the movements and again observe what happens. Now you have completed shoulder AROM. Actually, at the right upper corner, you can see the total disability already. It is like a running cricket commentary. Wow! It was so fast and cool. Movements are in degrees. You enter the observed value over the normal value. Spreadsheet calculates the loss in degree and converts the loss to percentage loss of movement. For each movement, it finds percentage loss separately. One such example value is marked in a brown arrow in this slide. Then it adds percentage loss in all movements in each joint. Then it divides this total by the number of movements. You will get mean percentage loss. You can see that value marked in a blue arrow in this slide. Spreadsheet applies weighted to each joint. Shoulder 20%, elbow 20%, wrist 20% and hand 40%. Total maximum value of AROM division is 90. Here you can see the 20% weightage is applied for the shoulder. The value we got is 11.85%, which is marked with a green arrow. The steps are given in Form A, and the joint weightage percentages are given in page number 67. Finally, after doing this for all joints, what we get is MLA or movement loss in arm component. That means for each joint, weighted mean percentage loss is calculated. These weighted mean percentage loss values of different areas or joints are added to get the summary value of AROM division. Now, just a few words about the AROM of hand. Active range of movement of hand was included in arm component in Gazette 2018 in just one sentence. Gazette does not tell how to include it. It also does not give any examples. So the procedure has to be modeled on other joints. First you have to get the normal range of movement of hand joints. I took the normal AROM of joints of hand from Appendix 3 from page 110. But there are still other questions. How much importance should be given to different fingers or hand raise? Obviously, 100% loss of movement of MP joint of thumb is far more serious than 100% loss of movement of MP joint of little finger. What is the proportional significance or weightage to be given to each ray? How much of hand is a thumb? How much of hand is a little finger? I found the answer in the Gazette itself. There is a table in Gazette, page number 75, section C, named as 5.2 upper limb amputations. See this image and this equation 55 is equal to 30 plus 15 plus 5 plus 3 plus 2. If you observe carefully, you can see and verify this equation. Look at the item number 9. Hand through carpal bones is equal to 55. You take that value and keep it on one side of the equation. For the other side of the equation, look at the item number 10. you find the value of thumb through CMC joint, that is 30. To that 30, add fingers through MP joints 15, 5, 3 and 2 from point 13. On a pie chart, it appears as a full circle. That means the values are complementary. That tells us how to deal with the loss of AROM in each ray of hand. Based on the table, proportion of weightage to be given to each ray is deduced. I call it ray-wise weightage or internal hand weightage. Thumb is 30 by 55, index finger is 15 by 55, middle finger 5 by 55, ring finger 3 by 55 and the little finger is 2 by 55. I converted this concept to spreadsheet. It fits in one page. 17 entry points for AROM of hand, all made very easy. Point, click and enter. Note, none of this is cooked up. It's all in Gazette. Probably this AROM assessment of hand is of much help to hand surgeons for disability assessment. Next comes the question, what is the exact procedure to be followed for the assessment of AROM of hand joints? We have designed it very similarly like what is followed for shoulder, elbow and wrist. In hand, each ray is treated as one joint. Enter observed values for each affected movement of all affected joints in degrees. Spreadsheet finds the loss in degrees and finds the percentage loss. It does same for all joints in the tray. Spreadsheet also finds the mean percentage loss for each ray. On that value, ray-wise weightage gets applied. Finally, those weighted values of all the rays are added together. On the final total, apply 40% hand weightage as given in Gazette. See this theoretical example of total loss of AROM of right hand. We have marked AROM of all joints to 0. Look at the end of hand section within AROM division. Blue rectangle shows 100% loss of AROM on right side in hand joints. And also look at the end of AROM division itself. Green rectangle shows that after application of weightage of 40%, hand value is taken as 40. If there is no loss in other joints of the arm component, namely shoulder, elbow and wrist, the right arm component now will have a loss of 40% as shown in red rectangle. That means if whole of the hand is paralyzed, arm component will have a loss of 40%. Let us see two examples. If AROM of one thumb is fully affected, what is the effect? It will result in 100% mean percentage loss for thumb. When you apply ray-wise weightage of 30 by 55 on this loss, you will get 54.55%. That means 55% of AROM of hand is affected if all AROM of thumb is lost. Then what is the effect on AROM of arm component? See this slide. You know hand has 40% representation in AROM of arm. 40% of 54.55 is 21.82%. In other words, whole arm component is affected by 22% if all movements of a thumb is lost. Thumb has that much importance in arm component. That is more than shoulder and elbow and double than wrist. Note that in this theoretical example, I am considering only AROM of thumb in arm component. Prehension and grip is not considered. Similarly, if a little finger AROM is fully affected, what is the effect on the arm component? It would be 2 by 55 of hand and 1.46 of arm. That means little finger has little importance in arm component. Note, in this theoretical example also, I am considering only AROM of little finger. Prehension and grip is not considered. Finally, we have come to the end of AROM division of arm component as shown in this slide. The summary value of AROM division appears here. Here you add all weighted movement loss at shoulder, elbow, wrist and hand. Thus, we get the total movement loss in arm component. Let us call it as MLA and keep that value aside. It is one of the three values of the arm component. Let us go to the next division in arm component. Yes, it is muscle strength division. This is the second division of arm component where you find the loss of strength. Here values of strength of muscles are in 0 to 5 grades as per the scale of Medical Research Council London. We know this grading system very well. It is also made very easy. Muscle strength is measured in grades. You enter the observed value, spreadsheet calculates the loss in grade, converts that loss to percentage loss. For all muscle groups, the spreadsheet finds percentage loss separately, adds the percentage loss in all muscle groups in each joint, then divides this total by the number of muscle groups, you will get mean percentage loss. Spreadsheet applies weightage to each joint at this stage: shoulder 30, elbow 30 and wrist 30, and finally you add all the values together to get a single value for the muscle strength division. The total maximum value possible is 90. You have to note at this stage hand strength is already given 60% importance in hand component in prehension group and strength groups, so muscle strength of hand is not included in this division. At the end of this division, you will get weighted summary strength loss in arm component called SLA. Keep that value aside. It is one of the three values of the arm component. Next comes the third division in arm component. It is coordinated activities. Gazette has listed 10 coordinated activities in this division. Each coordinated activity has a maximum value of 9%. So maximum value of this division is 9 into 10, that is 90. The 10 coordinated activities in this division are lifting overhead objects, touching nose with end of extremity, eating Indian style, combing and plaiting, putting on a shirt or kurta, ablution with a glass of water, drinking a glass of water, buttoning, tying a nara or dhoti, and writing. You have to observe the person doing these coordinated activities and give scores from 0 to 9. Here, value of activities are in direct percentages. Total of these values is already weighted to 90%. Therefore, the loss of activity in percentages are directly added within this division. At the end of this division, you will get activity loss in arm component called ALA. Keep that value aside. It is one of the three values of the arm component. So now we are at the end of the arm component and have three values: MLA, SLA and ALA, each with a maximum value of 90. But we need a single value for arm component, and the maximum value permitted for arm component is 90. Then how to proceed? This is achieved by using combining formula. As we have three values, we have to use combining formula 2 times. Imagine a case with 43.2% loss in AROM, 18% in muscle strength and 30% loss in coordinated activities. At the end of the arm component in the spreadsheet, you can see these calculations happening automatically. Spreadsheet does a lot of work here. As I told you, this is called telescopic combining. First, it arranges the loss in divisions in the descending order, then it combines the first two values, finally it combines the resultant value with the lowest value. In this example, you can see the values arranged in descending order: 43.2, 30 and 18 in that order. In the first stage, it combined 43.2 and 30 and got 58.8. In the second stage, it combined 58.8 and 18 to get 65.04. That is the beauty of spreadsheet. It does everything automatically. Finally, you have a single value for the arm component. Note that the calculations on left and right upper limb are kept separate till the end. That is the end of the arm component.
Next comes the second component in upper limb, that is hand component. Hand has many functions and features. All the functional features in hand component have values in fixed final percentages. Depending on the clinical findings, you have to give the observed value. For convenience, these functions and features are arranged in three groups. First is prehension group with a maximum value of 30, sensation group with a maximum value of 30, and strength group with a maximum value of 30. The losses are in direct final percentages. The values are weighted already. So all these values are added directly into one final value. The assignment is such that the final value will not exceed 90. So in a way, hand is the easiest component. This slide shows the page 4 of the score sheet, where you can see the functions in hand component arranged in three groups. Because all the values are in direct percentages, losses also will be in direct percentages. Mean percentage loss and weightage system are not used here in this second component. These percentages are directly added to each other to get the final value of the hand component. You can see in this Venn diagram the groups in the hand component do not overlap, they are added directly. After we complete the entries in the hand component, we come to the last page of score sheet. Now we have two values, one for the arm component with a maximum value of 90 and another value for the hand component with a maximum value of 90. If there is involvement of only one component, we have to take that value as effective impairment in upper limb. If both the components are involved, then we have to use the combining formula to combine these two values to get a single value for impairment in upper limb. Depending on the value of the elements, higher or lower value has to be taken and combining formula has to be applied. Don't worry, this also happens automatically. As seen in this picture, we get the final effective impairment of that upper limb.
Now we are coming to the second aspect of medical disability, that is additional weightage or complications. These are also called extra points in case of lower limb. There was a single list of additional weightage in the manual of 1981. In this gazette, however, dominant hand and shortening are separated and unlisted and not restricted by 10% limit. In this slide, you can see that the list of additional weightage or complications from Gazette 2018 discusses the dominant hand and shortening initially at the top of the page. After that, following statement appears. Gazette says a total of up to 10% additional weightage can be given to following accompanying factors if they are continuous and persistent despite treatment. Pain, infection, deformity, malalignment, contractures and cosmetic appearance can have values mentioned in Gazette 2018. So, our spreadsheet also has the same approach. We have two sections in the additional weightage, non-limited additional weightage at the top and 10% limited additional weightage at the bottom. Just a few words about these percentages in this list. Actually, these percentages refer to the quantity or extent of manifestation produced by those particular complications when the functional loss is 100%. For example, if a person has 100% disability, he has 100% functional loss. In that person, as you know, the effective impairment after processing becomes 90%. If that person has severe pain, according to the list, he has 9% additional weightage. So, in this person, the quantity or extent of complication or additional weightage due to severe pain would be in percentage of 90%. That is 9% of 90% or 8.1%. In another person with 50% disability, effective impairment would be 45%. The same severe pain in this person will have the extent of additional weightage of 9% of 45% or 4.05%. By default, the spreadsheet also calculates in this method or relative percentages and relative 10% max. In short, this is called relative 10% approach. Why it has to be like this? Where it is mentioned in Gazette, etc. I have discussed in detail in the first video of this series. In short, it is based on this concept that complications are percentages of impairment mentioned in page number 70 Gazette 2018. However, some orthopedicians want the additional weightages to be applied in absolute fashion. In both of the typical cases mentioned above, they will take the full 9% value. At the end, they apply the 10% limit. I call that as called absolute 10% approach. If you choose that approach, you can select absolute 10% in the spreadsheet, and in this approach following is the result you will get. Finally, it is your stand. However, I prefer and follow the relative 10% approach. To change your approach, click on that corner cell H215. You will see a drop down arrow as shown below, showing two choices, absolute 10% and relative 10%. It is marked with an orange arrow in this slide. You can see the two choices as I told you. Select absolute 10% if you want that approach. The default value in this section is relative 10%. Change it only if you are sure. All green areas will disappear if you select absolute approach. The calculation done in blue rectangles also change to suit the approach. Even the reference sentences also change. However, note that during printing, your choice of relative 10% or absolute 10% will not appear for printing. As I told you already, I go for the relative 10% approach. It is backed by statements in gazettes. It is mathematically correct and ethically right. However, you can take your own stand. Two of these additional weightages need discussion. Let us see the additional weightage shortening. It's an independent and non-listed complication, so it needs to be calculated separately. In upper limb, if more than 1 inch of shortening is there, then it is considered at the rate of 2% per inch of shortening. In the observed value section, you can directly enter the shortening in inches and the percentage value gets calculated automatically in the spreadsheet as shown in this picture. In this theoretical example, from top down you can see how this part of spreadsheet works. This victim has 40% effective impairment on right side marked with a red rectangle at the top. He has no impairment on the left side. Then note that I have selected relative 10% approach highlighted in the green rectangle. Down the columns for the observed value at the end in blue rectangle you can see there is 2 inch shortening on right side and 3 inch shortening on left side. For the first 1 inch shortening, patient gets no weightage. For the next 1 inch shortening, patient gets 2% additional weightage. Similarly, on left side he has 3 inch shortening resulting in 4% additional weightage, that is shown in yellow rectangle. The weightage gets applied over 40% impairment and you get extent of complication or EXAIC of 0.8% for the right side. On the left side, because there is no impairment, EXE is also 0. On adding this 0.8% to the combined value of 40%, you get the final disability of 40.8. However, there is no impairment on left side, so disability is not calculated on left side. Final disability for both upper limb together is also 40.9, rounded to 41%. In this same theoretical example, let me change the approach to absolute 10% and see what happens. The results will be quite different. In absolute approach, the additional weightage directly gets added up and I got a EXAIC of 2% on the right side and on left side, though there is no improvement, EXAIC is still 4% because you are taking absolute values. On adding these values 2% and 4% to the combined values, you get the final disability of 42% on the right and 4% on the left side. Now you have disability in both upper limbs. Final disability for whole upper limb section is calculated using combining formula. It becomes 44.13 and gets rounded to 44%. As I told you, you have to take your stand. I do not follow absolute 10% approach. I prefer and use the relative 10% approach. The second additional point which needs discussion is dominant extremity. It is an independent and non-listed complication. It means it needs to be calculated separately. Some controversy in interpretation may occur here also, as mentioned in the previous case. Take this example of amputation of little finger with 2% impairment. In World Gazette, 4% was mentioned for dominant extremity. If there was loss of function of little finger which amounts to 2%, addition of 4% would make it 6% if you take the absolute approach. But in Gazette 2018, 10% is the additional weightage for dominant extremity. If you choose relative approach, what you get is 2.2%. However, in case of absolute approach, addition of whole 10% would make it 12%. Well, descent is a service road in the highway of life. You have to accept it. I prefer the relative approach which appears ethically sane, mathematically accurate and clinically appropriate. The relative approach is supported by various statements mentioned in Gazette and was discussed in conference sponsored by KOA in Hubli in 2015, and I have discussed that in my first video in detail. Finally, these additional weightages are added to the combination of components or effective impairment. That gives the value of medical disability in percentages. Actually, for Gazette, upper limb means functional combination of right and left anatomical upper limbs. If both upper limbs are affected, you have to combine the values of both right and left upper limbs to get the final value for impairment in locomotor system upper limb. The total value of upper limbs should not exceed 100%. You can see that in this last part of the spreadsheet. Calculations here are also automatic. And that's all about our beautiful spreadsheet. Now you must have understood the advantages of using spreadsheet in calculations for the assessment of disability. The spreadsheet way is easy, accurate, visually appealing, don't miss any points, no calculators, no mistakes, no need to look at tables, no confusion, and it is really fast. Before ending, Let me summarize this topic of disability assessment for orthopedicians. We have to memorize only 6 keywords. It is like memorizing the basic anatomical words like sagittal, coronal, medial, lateral, etc. in the first month of MBBS. 6 keywords are components, divisions, mean percentage loss, weightage, groups, functions or activities or features. In this slide, I have shown some usage of these keywords. Here are the points in Gazette which shows the use of combining formula. Permanent physical impairment is calculated using combining formula in cases of multiple amputees, in cases of bilateral involvement, in mixed cases, and when more than one system is involved. Let us see the small picture once again. Final impairment or disability is due to total of impairment to the extent of 90% and complications not exceeding 10% in case of 100% disability, which is symbolized with the formula D is equal to I plus C. And this is the whole picture or flowchart for upper limb. Before ending, let me salute this beautifully designed combining formula. Combining formula gives effective sum of two impairments which is equal to A plus B into 90 minus A divided by 90, where A is the impairment of higher value and B is the impairment of lower or equal value. I request you to please see the description for other links. Thank you very much for your patient hearing. Bye bye and all the best.